Hello, everybody, and welcome to another episode of the JavaScript Jabber podcast. Today we have a special episode with a special guest, Matt Pocock. Hi, Matt.
Hello, Dan. How you doing?
I'm doing well. It's great to have you here. Before we start, I have one thing I would like to mention. So there's the latest JS survey that has just come out, I think today, as of the time of the recording. And I would love for you to pick JavaScript Jabber as one of your favorite podcasts in this survey. Just to help us get the word out there, every little bit helps. So with that out of the way, let's get to Matt. So Matt, how have you been doing?
Good. Very good. I've moved house recently. My son fell about 5 feet onto a hard floor. He's absolutely fine, but he had a black eye for about 10 days. But other than that, I'm doing okay. Yeah.
Yeah, it's funny. Well, first of all, you need to mention that your son is 10 or 11 months old.
That's true. That's true. He's not 16 or something. No, he's 10 months old, and he's very small, and he fell quite a distance, but he's okay.
Yeah, it's surprising how resilient babies are. I mean, if they wouldn't have been, then the human race would have likely died out by now. But obviously, it's super scary, and we shouldn't drop them. but
Yeah.
but they are resilient, more resilient than we might expect.
Quite. Yeah.
And where have you moved to?
So just moved locally. So I live in Oxfordshire and just moved to another place in Oxfordshire. So I can see horses out my window. Oxford is like somewhere that distance, and it's nice. I really like it here.
So really an English country gentleman.
Quite, exactly. That's how I like to present myself. That's how I feel too. I just need my top hat, my monocle, and my pipe.
I know you, as I imagine most of our listeners do, from everything related to TypeScript. You have a TypeScript site, you have a TypeScript newsletter, you put out, I think, TypeScript related videos and other forms of content. To a lot of us, me, for example, you're kind of like Mr. TypeScript. I'm subscribed to your newsletter. Well, I'm subscribed to a couple of development newsletters, but yours is one that I open as soon as it arrives because it contains so much really useful and pertinent information. I've really learned a lot, and I'm not just saying it, to be nice. I'm saying it because it's true. So I would love, thank you. So I would love for you to tell us a little bit about your journey into TypeScript and maybe even your journey into software in general, because I know that you didn't actually start with software. It's something that you like grew into or decided to join or whatever we like to call it. So take it away.
Yeah, my journey into development in general is odd. I studied drama at university. After that, I became a singing teacher. So I sort of sung a lot at university and basically picked up singing teaching. I did a master's in voice and singing teaching, so in a drama school, and moved to London and was working as a drama teacher. And I lived in London, and I wanted to be an Oxford country gentleman. I didn't like living in the big city at all. And so this was around 2016, I think. And I thought, what's a skill that can take me out of the city that I can do from anywhere? And I've always loved computers. I made my own little websites when I was 12 years old, just with HTML. And I thought, well, okay, maybe I could do that for a job. And so I started making applications for my students, making my lessons more interactive. And I love teaching. I still love teaching, but I wanted to try something new. And it occurred to me that I could go and get a job doing this. And so I did and became a junior developer. And I went from junior to mid to senior pretty quickly. And around when I was a mid, I started picking up TypeScript. And I was always just basically a JavaScript and TypeScript person. I did a little bit of PHP, but really just that. And I started to...
So what year was it when you started dabbling in TypeScript?
About 2018, I think, would have been. Yeah.
Okay.
So it would have been out, I think, for about 6 or 7 years at that point, and maybe even 5 years or so. And from that point, I was working professionally, and there was one particular project as well that had just really brought home the power of TypeScript to me, which was this project. We were the front end team working with the back end team in a totally different language. And we would make these contracts for linking up the front end and the back end. And they weren't very sophisticated. They were just kind of JSON blobs in Google Docs. And these contracts, the back end team never quite implemented them the way we wanted them to in the front end team. So, you would have camel case or instead of snake case, or the other way around, or something would be misspelled, something would be nullable when we didn't expect. And this would cause bugs. This would just break our front ends. And when we started adopting TypeScript, which I really, really pushed for, suddenly, whenever a small change was made in the back-end architecture, it just meant we could change it in 2 seconds instead of 2 hours. It was fantastic. And so from there, I was just a TypeScript advocate at every job I had. And that led me into a bit of open source stuff as well. So I started doing, have you heard of a library called XState?
Yes, I have. It's
Yeah,
a state management library. It basically does state machines.
that's right. Have you had David on the podcast as well? David Khurshid.
I think we have. I would need to check.
Mm.
If we had though, I think I might have missed that episode. And to be brutally honest, I myself have not yet used XState.
It's a wonderful library, basically building state machines and state charts. And if you've ever done front-end work, you know that building front-end interfaces is really hard, actually, and you will often encounter bugs. And those bugs are often because you just haven't thought of a specific state that your UI can be in, things go out of sync and it all feels horrible. But state machines really bring that complexity to the surface and make it a lot easier to work on. And I was working on some complex applications like spreadsheets. Like I was building a video calling service where you could walk through a virtual room in an agency I was at. And XState was really incredible for that. And so I started doing a little bit of open source stuff for XState. Open source then led to me joining a company that got formed out of the XState core team. And I started doing DevRel for XState. And then I started teaching TypeScript. And when I started teaching TypeScript, it just went, something really crazy happened. And within about 6 months or so, I became someone with about 4,000 followers to being the TypeScript guy, to being this person. I'm not really sure how that happened. Happened quite quickly and happened seemingly without my knowledge or intervention. So thank you.
Well, I think it's a combination really of a couple of things. First of all, I think there was a real need in the market. I mean, on the one hand, Microsoft were communicating stuff about TypeScript, but it was kind of like information from on high, and they were doing it as a vendor, not as as a teacher. So I think there was a real need for teaching TypeScript, and everything else was like TypeScript in the context of something else rather than a focus on TypeScript itself. And I also think it helped that you're just a great teacher,
Thank you.
that you could bring your knowledge and expertise and your approach that you had from teaching other things and apply them to TypeScript as well. Um,
Yeah.
I am curious though. Maybe it's the fact that it's, I'm a bit old school. I came into software the more traditional route through actually studying computer science in the university. And there's a lot of formalism around type systems and stuff like that. So you kind of expect people that are really into type systems to have a bit more formal background. Um, and yet you're able to do this and pull it off and do it really well. So how did you fill in the missing blanks? How did you get
Yeah.
the knowledge, the background in type systems and stuff like that?
That's a great question. And I think probably there are still blanks in my knowledge that I don't know about, because I often feel, and I think a lot of people who come into dev as a second career feel this. They feel like, oh, I missed out on something crucial. There was something in a CS course that I never took that I never quite got. And I think a lot of people feel that. But as it turns out, TypeScript operates on a relatively high level. You don't need to know a lot of the deep stuff. I'm still like, I still find it hard to explain like covariance and contravariance in a sentence. I never quite know if I'm using the terms correctly. And it has felt to me, I feel like if learning that stuff would benefit the people learning TypeScript, I would teach it. If, for instance, contravariance and covariance was mentioned in TypeScript errors, I feel like I would need to teach it. But as it turns out, me not knowing about that stuff, I think actually helps in terms of explaining it to people, because I'm not trying to layer on all of this extra kind of nomenclature and language onto what are relatively simple concepts. If you understand what a subset and a superset is, you can kind of understand what TypeScript's doing in a lot of cases. And so I do feel a bit like, oh, maybe it would have been good for me to do a CS course, learn that stuff. But actually, I think not knowing it, not having the curse of knowledge, has benefited me in weird ways too, making me closer to my learners.
First of all, I totally get that. I also have to say, again, even though I came into software the more traditional route, I actually started before I learned. So I did start as a hobbyist, as a teenager, and then after several years of just basically, doing whatever seemed to make sense, I went to university. But it's been so long that effectively I think every technology that I've learned I'm no longer using, and every technology that I am using is stuff that I learned after I actually finished my universities, that part of my career. So I totally get that a lot of what we learn is the stuff that we pick up along the way, and in fact the thing that I love most, it's the biggest challenge around working, I think, in software development, but it's also the thing I love most, is the fact that you constantly need to be learning stuff and updating your skill set and knowledge and whatever. And we'll probably get to how you yourself manage that, especially with TypeScript, but with other things as well. But before that, I would actually like to share something about the way that I got into TypeScript, which was a bit different than you, I think, or maybe not. We will see. I got into TypeScript a little bit earlier, around I think 2014-15 is the first time I actually encountered it. And I have to tell you that my initial reaction was very negative. The reason was that back at that time, Microsoft, all the examples that were coming out of Microsoft were around classes and interfaces, and they were showing, this is how you implement class hierarchies and interfaces and doing it safely and stuff like that. And to me, it very much felt like Java or C Sharp. And I left Java and C Sharp and went into and got into JavaScript and enjoyed JavaScript much more than I ever did Java or C Sharp. So the last thing that I wanted was to go back. I think that the terminology that I was using back then was, this is a poor man's Java. And I basically said, kind of a little bit reflected some of the attitudes that DHH proclaims still to this day, that, I like the freedom, I like the duck typing, the monkey patching, I don't like to feel constrained. I've got tests as if I need guardrails and stuff like that. And it took me a while. It took me a couple of years to realize the value the TypeScript actually has. When I started using TypeScript without um, without classes and interfaces. Did you go through a similar phase, or was it great for you from the get-go?
So it was great for me from the get-go, I have to say. And I feel like, I'm not sure when TypeScript implemented JSX, but that's what they did. They implemented JSX and a few sort of niceties to basically work better with React. And I was working on a React app at the time that was in JavaScript, and we translated that over sort of slowly to TypeScript kind of as we were working. And it was just great from the get-go for me. So I never actually received that marketing of like, oh, this is the new C# or something, or this is like, I don't think I really sort of thought about classes and interfaces. And actually, to be honest, React was quite class-based at the time. So no, I didn't have that. I immediately saw the value, and I immediately started putting it in a React app, which was mostly functional.
Hmm. The other aspect of it that was initially problematic for me, um, and to an extent it still exists, I guess, is the fact that the way that at least initially I thought about it is that I would write the JavaScript code and then I would add the types in.
Mm,
And what happened was that the JavaScript code, at least initially, would come very fluently,
mm,
very quickly. But then I would literally like sweat bullets adding all the TypeScript in. Now, part of it
mm,
was that obviously I didn't know TypeScript well enough. Maybe I still don't, but also that I was doing some more extreme dynamic style coding with JavaScript, and that
mm,
didn't really sit well with the way that you might write TypeScript.
mm,
So there I was like sweating bullets about getting the proper type interfaces, and I'm kind of anal about these things. It has to be perfect. It can't just be any or stuff like that.
mm,
And I was thinking, hey, I'm spending more time on implementing the types than I had been on the original logic in JavaScript.
mm,
And and it's weird because at the end of the day, all this type information is basically stripped out. So when it's
mhm,
actually executed, it's just the JavaScript back again. So here
mm.
I am putting all this effort into something that has literally zero impact at runtime. And it felt kind of, redundant.
You can feel like, oh, the feature's done. I can see it working. Why do I have to do all this extra effort
Exactly.
to just paint it? Really, to just the car's working. I don't care what it looks like. And I think if I were to rebut that, I think because I do, I think I didn't have a long lead in as like a JavaScript developer really before becoming a TypeScript developer. I
Hmm.
had maybe 2 or 3 years or so. But folks who've been writing JavaScript for a long time before that, their habits are absolutely set, like, and all of that sort of dynamic stuff, like the monkey patching and all sorts of patterns are kind of, TypeScript makes you be a lot more boring. It makes you write
For sure.
in quite a sort of dull way. You don't get a lot of the same freedoms that you do when you're working in JavaScript. Of course, I would argue that is quite a good thing. It means that code generally starts
Boring
looking a
is
bit
good.
more like each other. Boring is good. Yeah, boring is good. Boring is efficient. Boring means that you can switch projects easily. Boring means that, boring is good. And I would say that what I start doing now, having worked in TypeScript for a long time, is I do more type-driven development now. Is I'm thinking about the types and the flow of the types really before I'm thinking about the runtime architecture, or perhaps sort of as part of that. And so I tend to type my function parameters before I implement them. So I'll just get all my functions in a row and understand what's happening, and then I will start to implement. So I think that is definitely, for someone coming from a long time JavaScript background, that's quite alien, because that's really, I need to think about the types before I implement the rest of it. But that's how I'm certainly thinking about my TypeScript dev.
So First of all, by the way, one of the things that also clicked it for me was when I started thinking about it like tests.
Yeah.
Again, you can write all your code without tests, and tests themselves, again, have zero impact on runtime. They're not part of the runtime bundle. So again, you could say, well, all the tests are stripped out effectively. But
Mm,
I, I really hate code bases without tests. It
mm,
makes me feel insecure.
mm,
Um, and even though I sometimes I'm lazy, I sometimes loathe writing all the tests that I need to, but at the end of the day, it's worth it. And I
mm,
look at the same way with types, and I've gotten really to the point that I really can't write JavaScript anymore. Even though I love JavaScript. JavaScript for a long time has been my favorite programming language. I've been doing it
mm,
since 1998. I'm really dating myself.
mm,
So yeah, for a long time,
mm.
more than many of our listeners have been alive, maybe.
I
But
think so.
but um, but these days, I'm literally like I literally like if I'm writing just pure JavaScript without a type definition, it feels like something is missing.
Mm. And I think a lot of people feel that way as well. That seems to be why TypeScript is so sticky. It's not like people adopt TypeScript and then, oh, in my next job, I'll just write JavaScript because that was too hardcore. No, people who tend to go into TypeScript, they don't tend to leave because you're right. It just doesn't feel the same. I think there was a quote from the TypeScript documentary that really stuck in my head, which is when you're writing in JavaScript, you feel like you're carving in stone, basically. It's really hard to then change that resulting code. Code feels a lot less malleable, a lot less movable, a lot less portable. You just can't change it with the same rapidity and the same sureness. Whereas in TypeScript, if you move something to the wrong place, it will give you all these warnings. You can check your entire project, and you can have a lot more security that your code works the way you think it works.
I totally agree. And this was actually, I literally experienced this very recently, as in a few days ago, because
Mm,
at where I work, which is Sisense, we've got a lot of legacy code.
mm,
And one of the topics that I'll probably bring up with you is, how to deal with legacy stuff and how to port existing JavaScript projects to TypeScript. And I see bugs in the code that could not happen
mm,
if the code had been written in TypeScript.
mm,
And there are a lot of challenges in adding TypeScript into an existing JavaScript project, especially a large one. But for me, the biggest challenge from what I see is fixing all the bugs that you discover when
mm,
you add TypeScript. Because ideally, adding TypeScript into an existing JavaScript project is basically just adding types.
mm,
You don't want to be touching the business logic. But what
mm.
I find is that I find bugs in the business logic, which I then need to fix. And
Yeah.
this to me is like the biggest hassle of adding Java TypeScript into an existing JavaScript project.
Mm. That's quite a good hassle to have, right? Like the hassle of making your code better, I suppose. And I mean, in some ways, it makes you code a bit more defensively. You need to make sure that that your inputs are all correct. But yeah, you're absolutely right. And that was definitely the experience we had. Is that when I first introduced TypeScript to that very first project, is oh wow, that's a code path I just didn't see was possible. Or yeah, that's okay. That could either be a string or union, or string or number in that place instead of just a number. You want to dive into like how to migrate? Because I've definitely got some advice there.
Yeah, you know what? I was saving it for later, but it seems to
Yeah,
naturally fit in here. So
yeah,
let's say I'll give the background. Let's say I have a large scale existing JavaScript project. Maybe it's React, maybe it isn't. I
mm,
don't know if it matters really. And and no TypeScript in sight. And I want to add TypeScript into this project. I can. What's the best approach? Should I do like sit down and just try to do it all in one go? Should I do it incrementally?
mm,
If so, at, what would be the unit size? How do I estimate the effort? How do I justify it to product and management that I'm going to be spending all this time, yet not adding a single feature into the product? What can you say about it?
Yeah, so it's a huge topic. Let's add another assumption as well. Well, let's assume that the code base is actively being worked on and that there's features being added as well, because that seems to be the most common case.
Oh, yeah, for sure. If it's not worked on, then what's the point almost?
Exactly, right. So like you're working on an active code base. You need the CI to remain green at all times as well. You don't want to be doing things which make the CI red for a certain period of time. And you don't want to be messing people's stuff up. So there are a few ways that you could do it. You could take every single JavaScript file, turn it into a TypeScript file, just like with a command or something, and then boom, you're in TypeScript with 0 types. And then perhaps you could ramp down the strictness to the point where you get 0 errors, right? That's one way to do it. That's a bad way to do it. The reason for that is that, first of all, you break everyone's PRs. If anyone has any existing PRs, then they literally can't, that you would have to do all sorts of shenanigans to make their code work.
You probably want to tell everybody we're doing it on this week. Merge all your PRs, don't create any new PRs, and this is what we're doing.
Yeah, big disruption, no good. Yes. Especially to a big team working on a big monorepo, let's say. And then the thing that's hard after that is that it's really hard to ramp up the strictness in a way that's incremental, because you want the CI to stay green. And if you say, okay, today we're going to turn on the no any rule, then you turn it on and it affects your entire code base. So the CI is basically red. So I think that approach, which a lot of people do take, of turning every file into a TypeScript file, is a bad approach. Because what you should do, I think instead, is you should add in a TS config into your project, and you should install TypeScript. And you should choose the highest level of strictness that you're going to get, your desired level of strictness. And when you do that, you then take it file by file. And you're just turning, basically, in one PR, you would just turn one file into a TypeScript file. And by doing that, you might find external libraries that need to be imported types and stuff, and you fix the types in there. You can use like any at this point as well, if you need to get around it. But that's what I would start with. And the key there is that the order of the files that you choose is really important, right? Because let's imagine that your code base is like a tree. You've got the files that are imported very often, sort of at the top of the tree, and they're sort of like spreading down like that. And the files that are used in lots of places, you want to do those first. And you want to translate them to TypeScript first, the ones with the fewest dependencies. You can use a tool like Madge, I think, to basically walk up the tree.
You want to start with the ones that have the fewest, that depend on the fewest things, but on the other hand, that a lot of stuff depends on them. That way, you create small disruption, but quickly bring on the most amount of value.
Yes. And the reason for that is, so like your utilities folders, for instance, or the files that contain, math or something, or, things that are used in lots of places.
Which project does not have a utils folder?
Exactly. Right. That's where you want to start. The reason is that if you start further down the tree, then your TypeScript code is going to be depending on JavaScript code. And that's a really nasty place to be, because all of the JavaScript code is just going to produce any's. And so those any's are then going to filter through. Whereas if you start with a TypeScript file that has no JavaScript dependencies, you're going to be in a really, really good spot. And then you just slowly go down the tree. And so Sentry has an amazing article about this. They basically did this for like a 2 million line code base.
Or maybe now or later?
Yeah, I'll drop a link certainly later. But if you Google Sentry TypeScript, it will come up. And that's Sentry, the error logger, not like, a century of time. And what they did was they basically said, okay, we're just going to share this out among the devs. Whenever you have a free minute, whenever you finish your tasks for the sprint, just translate a TypeScript file and go down this list of all of our dependencies. And so they slowly did that over the period of about 2 years. And it took them a while to get it done. And I think there are still files in that code base. It's an open source code base as well, that are still JavaScript and mostly like tests and things that they just haven't needed to change. But every new file, of course, is still in TypeScript. And so that was the process they followed. And I think it worked really, really well. I interviewed Priscilla, one of their devs for my course, and she sort of explained the whole thing. And that is the process I would follow. Basically, make a dependency tree, work out which ones to do first, add in a TS config with a maximum strictness, and go file by file, keeping that CI always green, making sure you're not stepping on anyone's PRs, and maybe during people's PRs, they can turn things to TypeScript.
You know what occurred to me? Maybe is an idea for a feature if anybody from the TypeScript dev team is listening, or maybe you'll tell me it's a stupid idea, in which case don't do it. It might be beneficial to have like two levels of TypeScript support. So if your TypeScript or TS or TSX file, then you go with the strictest definition. But there's a transitional period that you're taking a JavaScript file and then you're translating into TS. It might have been beneficial to have like a TS star or TS, TS2 whatever file that has like less strict settings, so which would allow you to gradually get that file to where you want to go without having to lower. And that's because one of the things that I'm seeing is that unfortunately, at least with some of these legacy projects, some of the files are pretty large. You unfortunately encounter like a 1,000 line file, and now obviously you can say, okay, then part of the project is also splitting up such large files into smaller files, but that significantly increases the scope of the project. So ideally, you would like to handle that. You would like to keep the file structure as is. It's also good for Git and stuff like that. And in that context, taking a 1,000 line file and turning it all into strict from JavaScript into strict TypeScript in one go can be fairly challenging. Now, obviously, you can turn off various rules in the scope of that particular file, I guess, but that's a pretty big hassle.
Well, not quite. I mean, you could, I suppose, there is a very complicated way of doing that. But in general, if you have a TypeScript project, the rules apply equally to every file, essentially. One thing you could do with a file like that is just use any in lots of places, or TS ignore all the errors, or
yeah, but then that means that you need to support any everywhere, which you may not want to do.
Yeah, and if it's a file that's dependent on a lot, then if you have any in that top file, it's going to spread down like a virus into all of the others.
Exactly.
So yeah, it's just hard. I think there will be situations like that, and honestly, starting with the utils folder, that's probably going to be the hardest to type, right? You might end up needing some generics in there, some generic types, some generic functions,
because we'll get to that.
Yeah, we'll get to that. So, but you might need that, and that's a hard place to start if you're just beginning a TypeScript migration and upskilling your team. So usually you do need someone who's going to be, the TypeScript wizard on that team to tackle the utils file, so that everyone else can benefit, basically.
Which brings me to another point. I've talked to people who are basically thinking about doing this transition. And they said, well, the code base is one challenge, but the other challenge is my developers. Now, these days, you're getting more and more front-end or JavaScript developers that are effectively TypeScript developers, but there's still a lot of JavaScript developers who are not TypeScript developers out there. And the reality is that I had a team lead tell me, you want us to go full TypeScript, but my devs don't really know TypeScript. And it's a problem if I effectively have my developers working in a programming language that they don't know. What we will end up is them using a lot of any's. And if I don't allow them to use any's, then they'll potentially get stuck. And now, obviously, you're obviously working to address that by teaching developers TypeScript. But if I have an existing team, like, what would be the best way to get the team into TypeScript?
Well, the cool thing about TypeScript is that it's not a really heavy lift in terms of learning. If this is what I don't like about other languages that are sort of trying to solve the same problem as TypeScript, which is basically adding a type system to JavaScript. So things like OCaml, or I'm not sure, I don't know OCaml that well, but I know that's one of its uses.
ReasonML.
ReasonML, Elm, things like that. I don't like those because they're a much heavier lift in terms of learning.
Oh,
You
it's a
have to
different
learn
programming language.
It's a different programming language. And TypeScript, people will say, surely that's a different programming language, isn't it? Well, no, I don't think so. It's really just a sort of set of decorations on top of JavaScript. And you're using a lot of the same intuitions as you have in JavaScript just to be able to add types to it. So I think when you do that, you do need someone who I think can lead or be the go-to person at that company who can answer people's TypeScript questions. So I think a team that's just sort of like with zero TypeScript knowledge whatsoever going into a TypeScript migration is, I think, going to have a pretty tricky time unless they invest in some resources to, help them out. But yeah, you do need that person at the company who can just be the go-to TypeScript wizard to say, help me out, please. I'm just stuck on a problem. Because if you don't develop that intuition, it can take a while to muscle through on your own. But I think the basics of TypeScript, I think you can get productive in TypeScript pretty quickly. Was that your experience of learning it?
Well, to be fair, I came into TypeScript as a very experienced developer who's been around the block, and I actually started with statically typed language. Well, that's not actually true. I started with BASIC, but I pretty soon got into statically typed languages. So most of my programming career was actually spent in statically typed languages. To an extent, going to JavaScript, I felt the liberation into an extent of putting all the static types behind and just saying the wild west, as it were, of it can be whatever, and dynamic object structure and whatnot. By the way, one of the things that I like to say about TypeScript is that the tasks that they pick for themselves is literally herding cats, because you have the poster child for dynamic programming, programming language which is not only dynamically typed but dynamically structured, and everything is about duck typing and stuff like that. And then you're trying to implement a static type system on top of that. It's pretty amazing what the TypeScript team has been able to achieve in that context, and I guess we'll get into some of the finer points if we have some time later on in this podcast. So, for example, I learned generics, or templates as they were called, in C++. So by the time that I got to TypeScript, the concept, and then I used them in Java and in C#. So by the time that I got to TypeScript, I was already familiar with these concepts. So it was less of a hurdle for me than it might have been, had I not had that background.
I think you can. One thing that occurs to me is that you don't necessarily need to learn the really advanced parts of TypeScript in order to get productive with it. Often there are kind of two areas, or possibly three areas, actually, I think, in terms of the level of TypeScript that you need to interact with it, which is you probably need someone on your team who's able to write kind of library level TypeScript code, like someone who can do
the
generics
utils
and
folder. Yeah, you
utils
know what?
folder, exactly.
Let's hold off on that, because I actually want to get into that specific point and a bit later in our conversation. And before that, I have a different question for you. So, yeah, what I really wanted you to ask. So you're obviously a TypeScript aficionado. You really love the concept. You love the language. By the way, one of the other things that I think we forgot to mention about the big reasons for TypeScript success is just the integration with development environments. This whole thing about, one of the things that kind of came out in that video that you mentioned about TypeScript was the fact that you can look at it as a programming language, but you can also look at it as a tool, and as a tool for the JavaScript programming language. And the great integration that you had from almost day one with VS Code is, I think, it made a huge difference. Obviously, now you also get the same level of integration with, with other tools like WebStorm or whatever. But
Mm,
without that level of integration, I don't think so. The whole thing of this TypeScript service that's running on your
mm.
computer, and that the editor can communicate with it, and it does all the type checking for you in real time. So that was a huge win.
Yeah.
And coupled with that is all the type information that they created for existing frameworks and libraries. So all
Mm,
of a sudden, if even if I'm just working in JavaScript and not TypeScript, I'm getting a lot of the benefits of TypeScript.
totally. So this was about 11 years ago when TypeScript first kind of came out. And the thing that I think a lot of people probably, or brought a lot of people in, was one of my friends, a guy called Johnny Riley, who ran the Definitely Typed repo.
Hmm.
He spent a weekend, I think, when his son was very, very small, making types for jQuery, and basically like typing jQuery. So you suddenly had autocomplete for everything jQuery could do. And he wrote these beautiful JS comments, which are still there to this day. And I don't know. I mean, that level of integration, the fact that not only was TypeScript and VS Code kind of being built at the same time, but TypeScript, the VS Code team went to the TypeScript team and said, we hear what you're working on is pretty cool. Do you mind if we use it to build VS Code? So I don't think VS Code, because it was such a complex JavaScript application, they really wanted a strongly typed language. So they were built actually at the same time using really within Microsoft. Amazing. I don't know.
Yeah, that's the other thing. I know. I mean, when I look at projects that somehow get by without TypeScript, they're usually very
Mm,
small, and it's a legitimate thing. But
yeah,
all the projects that I've been working on in the world of JavaScript development, be it in the browser or be it in Node, in the past decade, have been really large. I
yeah,
mean, projects where you've got teams of at least 10, sometimes as large as 50, working on code bases that can be up to 1 million lines of code.
yeah,
Doing that without typing is bordering on insane.
yeah. Because I mean, just in a very simple terms, when you're working on like the more developers you add to the project, the more likely you are that one of those developers is going to make a mistake. You know, just the number of mistakes goes up as the number of developers working on something goes up. It's just, how maths works. And when you have something that you can just sort of stick in a project that you can run on your CI, let's say, whenever a PR comes in, and just check if anyone's made a typo, check if a whole class of those mistakes, that's just so valuable for teams. And especially when you have code that's being worked on at the same time, you want to check if that code is compatible with each other. Having an automated system for doing that is incredible. And of course, TypeScript doesn't catch everything, but it catches an enormous amount for a very low or comparatively low level of effort.
I totally agree. And there's the other side of it, which is the fact that JavaScript is so very forgiving, and so is the browser, and so are basically almost any environment that runs JavaScript. So
Mm,
again, people would say, "Why do I need JavaScript? I've got tests." But
mm,
the thing is that the environment is so forgiving that you can have a catastrophic failure and still pass the test. So unless the
mhm.
test is specific enough, um, you can still get by with bugs. Like the I mentioned before that I'm fixing legacy software. I'm catching a lot of bugs. These are often systems that have end-to-end tests, let's say, in place, and the end-to-end tests
Mm,
pass because the
mm,
browser is such a forgiving environment.
mm.
Um, but it doesn't change the fact that you've had a stupid bug in there, that you've got some undefined in there where you should have had some value, and it's somehow able to muddle through until maybe it doesn't.
Yeah.
Anyway, so I would like to get to my next question. And TypeScript keeps evolving and getting new features. What version are we at? 5 point what?
I think we're 5.7 now. Is that right? Let me check. 5.7 is the new beta that's coming out, I'm pretty sure.
Okay. So first of
Yeah.
all, let's start with one thing. Let's start with what do you, I think we kind of covered it, but maybe you can be more explicit about it. What do you love most about TypeScript? But the other side of that equation, is there anything that you hate about TypeScript? And if so, what is that?
Yeah. So there are lots of things I don't like about TypeScript, definitely. Lots of things I think they could improve, features I wish they would add. I think we've got the love. The thing I love is that it makes my IDE 10 times more powerful. It makes developing stuff easier, makes me feel more secure. So let's go on to the fun stuff, the stuff I hate. Flow, which is Meta's sort of version of TypeScript, it's a version of strongly typed JavaScript. It has something called exact object types. What that means is that if you create an object in Flow and you say, okay, this is an object of this type, then you basically can't add any extra properties to it. So if you have an object with A, B, C, then you can never, in any situation in Flow, add a D property to it. But in TypeScript, in various situations, you can do that. So TypeScript has open objects that are open to extension. And that means that in various places, you can actually get into situations where you have these random sort of properties kind of floating about. And if we were doing code, I could show you, but you can read my chapter of my book on exact object types, which is free, by the way. It's you just Google it. And
What's the
that
name of your free
means
book, by the way?
it's Total TypeScript Essentials. So if you go to totaltypescript.com, click book, you'll find it. And
Highly recommended.
oh, well, thank you very much. This means that various things in TypeScript are not as good as they could be. So object.keys, for instance, when you're iterating over an object's keys, when you iterate over A, B, and C, you would expect the type of that to be A, B, or C, literals A, B, or C. But in fact, it's just a string. So it's extra wide. So it's wide because it's sort of, TypeScript knows, oh, well, it could contain D, and I don't actually know about that. And that means that extra wide type sort of gets a bit frustrating to use, because when you go to index back into that object, it's horrible. So I wish TypeScript had exact object keys like
Isn't
Flow.
it something you can configure somehow with tsconfig?
It's just so baked into the way that TypeScript works that it's impossible to go back. It's a feature I wish they could add, but I would be shocked if they managed to do it, honestly.
So you're saying it's such an integral or core aspect of the way in which they structured TypeScript, the language, that backtracking on this now would be extremely hard. Like adding a
100%.
Boolean flag in the tsconfig could theoretically be possible, but practically it would be very challenging.
Very, very tough. And I suppose they could add some sort of keyword, like the exact keyword to make it work. Because Flow has exact objects by default, but you can make them like TypeScript if you want to opt in. But yeah, I just don't think they do it, because it does have benefits too. It means that you can pass wider objects to smaller ones, which is useful when you're doing things with classes and stuff. But I don't know. I don't think they're gonna get around to it, which is a shame.
Anything else that you would wish?
There's some more complex stuff, like the way that TypeScript works with generic functions. If you can actually pass types to certain functions, but then if you pass one type, then any other types that you don't pass don't get automatically inferred. So this is called the partial inference problem. I wish they would bloody fix that. I was talking to Tanner Lindsley about this, I think 3 years ago, and he was saying, oh, they might fix it, and they've been shaping up to maybe fix it, but it just makes certain APIs impossible, basically. And it makes things a little bit harder. So I would love if they fix that too.
You know what? I was saving this question for later, but since you brought up type inference, maybe you can explain briefly what type inference means, and
Yeah.
then you might say what is your attitude towards type inference. Like if there's a place where type can be inferred, should it always be inferred, or do you prefer to be explicit sometimes or always? So let's start with what is type inference and go from there.
Yeah. So let's imagine you have a function and that function can either take in a string or a number, then there are some things that TypeScript can't infer. Like, let's say you're creating a function. Whenever you create that function in strict mode, you have to annotate the parameters. That's usually where most people are writing their types, actually. So imagine this function takes an input of string or number. Then we do like an if statement, and we check if the input is a string. If we do, then we call like input.toUppercase or something. Otherwise, we do something else. So if you imagine there are kind of three blocks there. There's the function, there's the first if statement where we're checking if it's a string, and the second if statement if we're checking if it's a number. Now, without this magical thing called inference, we would have to add types in all those places, right? We'd have to say, okay, it's a string or number up here, it's a string here, and it's a number here. But TypeScript can actually infer that based on the behavior of our code, based on it just looks at the code, it says, oh yeah, it's an if statement that's checking this thing. It must only be a string in this particular closure.
By the way,
Otherwise,
just to interrupt you briefly, that was one of the magical aspects for me of TypeScript that initially I didn't get, because again, I came into, like as I said before, my background was from statically typed languages, which usually don't need these types of shenanigans, because something is a strict type. You don't have to infer that, hey, it's this type in this context and that type in that context. You might do some crazy stuff around templates to narrow the passed-in types, but within the code itself, you don't. And it took in the realization that TypeScript does static analysis of your code and narrows the types based on what it reads in your actual code, like ifs and stuff like that. And now you also have type guards and stuff like that. That was pretty amazing to me. And once I realized that was one of the things that really got me to really appreciate TypeScript.
100%. And it's such a hard problem as well. Imagine building that from scratch, something that looks at your code and understands, okay, in all of these places, this is what type these values are. It's crazy they pulled it off. So it works. This is what's called narrowing in TypeScript. It works with switch statements, works with objects, works with, now it actually works with functions too. So you can create a function that checks if something is a string, and it will automatically, you don't need to add any type annotations apart from just the input. It's amazing the way it works. So that's what type inference is. It's TypeScript looking at your runtime code and inferring the types from it. And I have an exercise in my course where I basically say, okay, we do all of this code and I basically annotate every single place that you could possibly annotate, like on variables, on function parameters, on function return types as well. And I just
function return types, by the way, is where I usually think about inference. Like you said, parameters usually need to be typed. I mean, because you really can't infer the parameters there. That's the entry point. But the exit point is certainly the place, there's something that you can often infer. Like, if it's an add function that takes A and B and returns A plus B, if both A and B are numbers, then obviously A plus B is a number. So the question then really becomes, if the function return type can be inferred, should I be explicit about it, or should I just let TypeScript infer it?
Yeah. So I go back and forth on this. This is a tricky question. And there are various cases where it's obvious that you should type the return type, because what you're saying is when you create your function definition, basically the types at the top are your description of how the function should work. And when you're in, let's say, a library setting or a utils folder setting, you probably always want to create those types, actually, because it's a way for someone who doesn't want to read the body of the function to just go, oh, I see what this is doing. Right, I understand. Okay, it's a function that takes in a string and returns an object with a value in or something. So what it means then to type those is that it gives you a contract that you have to be able to meet. And so it means that this is type-driven development. You're taking the types and saying, this is what I want to create, and then you're creating it. If you don't do that, then it does give you a bit more flexibility. It means that the things that you're returning, for instance, from your function are just like automatically inferred. This is a really good example is React components, for instance. They are always, every single React component is always going to return the same type, always going to return a type of React.React node because you're just returning JSX. So in every single React component, you're going to be returning the same thing. And to annotate a React component's return type just seems a bit weird to me. There are lint rules that force you to add a type to every single function return. And I find those extremely annoying because there are tons of use cases and tons of cases where I don't want to add the return type at all. But it is sometimes beneficial to just give yourself a guardrail, give yourself a contract that you need to meet. And honestly, I find myself doing it more and more and more because it just feels good to be able to say this function does this thing and then implement it.
So basically you're saying is if I'm doing the function outside in, I'm actually specifying the function parameters and return types before I write the function body, then I've got the return type as a validation that what I'm returning actually matches that type. So I get two benefits. I get, anybody looking at the function declaration knows what the function will be returning without having to read the code. Although, there's an interesting point about that. I'll get to that in a second. And the other aspect is that the fact that you're providing a guardrail for yourself, making sure that you are in fact returning the correct type.
Yep, absolutely bang on.
The interesting thing is, again, looking at my experience with other statically typed programming languages, there are programming languages that actively advocate the type inference approach, where ideally even though they're statically typed, their inference is so good that you're expected to hardly ever write any types, because it's basically you don't need to think what the types are, which again takes me back to this aspect, because in a sense, if I don't really if my all my assignments are initializations, so all my variables are const, like not variables, they're immutable. To an extent, I almost don't need to think about the type. So I'm assigning the return value of a function into a variable. It is what it is. I know that whichever way I use it is correct. I can only pass it into the appropriate functions, or if I do the dot, I'll get the correct completion. I don't need to be explicit about the type.
There are situations where, of course, you do want to be explicit about the type, where you know more about the type that something should be than TypeScript can infer from the runtime. A really good example of this is like index signatures. So, for instance, if you have an object that okay, I'm going to be adding keys to this dynamically, like IDs, for instance, and they're going to have this value of property on them, then you need to tell TypeScript that up front. Because if you just initialize like an empty object, then TypeScript is just going to infer it as an empty object, basically. And so adding that level of
just make
stuff
it a
is
map.
important. So make it a map. But even with a map, you need to,
give the map, you're obviously explicit. You're obviously explicit about the type. By the way, one of the things that kind of also blew my mind about modern TypeScript is how you can create types with string expressions. That you can actually structure, say, not, we gave example before about keys, that it's not just any string, it's a keys of an object, but it also can be a particular structure of a string. So a string that has like hello at the beginning or something like that, which is pretty insane to me.
Yeah, if you're following along at home, if you've got us in your ear and you're at your laptop, try just typing crypto.randomuid and call the function and see if you just hover over the thing that it returns, you'll see that it returns basically what it returns in real life is like a UUID. So it's like 5 parts of a string separated by dashes. And you'll see in the return type that it actually does the same thing on the type level. It's crazy. It's crazy that you can basically represent these strings in a type-safe way. It's absolutely bonkers.
Another thing that really confused me initially when I got into TypeScript, because again of my background with type languages working against me, with statically typed languages working against me, was the document dot create element. The fact that the type returned was based on the string parameter passed into that function kind of blew my mind. This was not
Yeah.
C++. They're like, this it's the fact that they had to do it from the get-go, because otherwise create element would have been pretty useless, and it's part of the DOM.
Mm,
But the fact that if you pass in the string div, the return type is HTML div, but if you pass in span, it's HTML span. If it's a button, then it's HTML button. It's pretty insane to me.
yeah, it's
And
cool.
I
I
think
mean,
that was from day one.
yeah, I think because that's another thing TypeScript does too, is it gives you a lot of confidence in these DOM APIs. And some of the DOM APIs are pretty funky, in terms of what they do. And
You talked about jQuery. The dollar
mm,
function in
mm,
jQuery literally could accept anything.
yeah,
And what you passed in really determined what you got out.
mm.
So the fact that it could infer what you got out based on the value of what you passed in was, again, pretty insane.
I can't believe they pulled it off. To be honest, like it is. I mean, that you've got an incredible team there. You've got Steve Luco, you've got Anders Hausberg sort of working on this thing.
Anders is my god.
Yeah, he's everyone's god. He seems like such a nice guy as well. And I've never met him in person, but I would love to.
I'll do a quick aside. You know
Uh,
that people know him from TypeScript and from C Sharp, but
mm.
for me, he'll be forever the person associated with Turbo Pascal.
Oh, really?
You know what Turbo Pascal was or is?
Don't think I do. I mean, I know the words, but I don't know the. I
So
don't know what
so
it was.
so Pascal is a programming language that originated back I don't remember if it's the 70s or the 80s, created
Mm,
as a strongly typed a language intended for teaching computer science in the universities.
mm,
Quickly open sourced, which made it fairly popular.
mm,
And what happened? So everybody working on PCs back in the day, back in the 80s or early 90s, was basically working in BASIC, which was a
mm,
terrible programming language in a lot of ways.
mm,
And then Anders, as this young man, released Turbo Pascal, which basically was an implementation of Pascal and an IDE. So it was both the programming language, the compiler, and an integrated IDE, which was miles ahead of anything else available at the time. Ran on really low-end PCs with blazingly fast compilation. So
wow.
all of a sudden, I went from writing slow code in BASIC to writing super fast code in Turbo Pascal, in
Wow.
Pascal. And it literally blew my mind, rocked my world, and made me into the developer that I am today in a lot of ways.
Wow.
So if I'm thinking about people that I owe my career to, Anders is high on that list.
Wow. I guess me too, man. Me too. I mean, he didn't invent TypeScript like a lot of people think, but his influence and his guidance over it. I mean, he's still involved today, still making PRs today. He's an incredible guy.
Anyway, so I have a few more questions. So we talked about the
Mm.
things that we like or did like, or you like or don't like about TypeScript. Um, by the way, we are starting to run long. I don't know how much time you have. I would love to have as much time with you as I possibly can, but don't hesitate to let me know that you need to stop or whatever.
I've probably got a hard stop at past, so in 18 minutes, sadly.
Okay, so maybe we'll just need to schedule a follow-on.
Yeah.
So I'll try to get one or maybe two more questions into there. The next question that I have is, again, given that new versions of TypeScript keep coming out, what recent or upcoming addition to TypeScript has you the most excited?
Yeah. So the thing that really got me excited was 5.5. And I want to get this right. This was 5.5 TypeScript, which built or added something that I just did not think they'd ever add, which was inferred type predicates. This is something I sort of touched on earlier, which is when you have a function that you can check whether it's a string or not, a thing that's passed in. Before, to get this to work in TypeScript, you would need to add this kind of slightly janky looking input is string return type, which checked whether the basically sort of duplicated the runtime logic in the type level. And Now you can just delete that and TypeScript will infer it automatically. This makes many things a lot easier. For instance, if you need to filter, if you have an array of things that might be string or null, then you can actually filter those with array.filter. And then you can write a little function inside that dot filter, basically just says a type of string, a type of input equals string. And before, again, you'd need to do this janky little thing, but now you can just delete that and it infers it automatically. So
So
it's just something
basically,
that has a huge downstream effect.
all the array utility functions or iteration utility functions now emit the proper type definition. I think I
Yeah.
saw this as well, and it also kind of blew my mind. And it will be especially interesting to see if it is able to work with iterator helpers. If they get
That's true.
that to work, that will be like really insane.
Yeah, that's very cool. Yeah, this was made by Dan Vanderkam, who's another TypeScript author. I think he went on like a coding retreat for a couple of weeks and just built the feature, his first ever PR to TypeScript, and they accepted it. And it's now an incredible, incredible feature.
Which again, I don't think we'll have enough time to talk about it. But again, one of the things that I especially learned to love about TypeScript is null safety.
Yeah.
People don't appreciate it, that
Yeah.
whether or not something is nullable is part of the type.
Mm.
And and if you pass a non-nullable argument in, then you don't need to worry about it being null. So
Mm.
all the if you're doing it correctly, all the null errors, that what's known as that, that famous $1 billion mistake, even though it's
Mm-hmm.
probably way more than $1 billion by now,
Yeah.
all those null references, if you do TypeScript correctly, it just
Yeah.
solves that.
And the fact it discriminates between null and undefined as well, which is that's like a strictness setting. So you can basically sort of turn that. I always recommend you turn that on, and that's part of strict true, which is TypeScript's sort of basic strictness level. The fact that it discriminates between those two as well is just, it can feel extra strict sometimes, but it just saves you an extra level of pain.
Yeah, I do wish, if I could have gone back in time to 1985 and whisper on Brendan Eich's ear, I would have said maybe not both, maybe just one or the other.
Yes, I strongly agree. And maybe just fix the thing where type of null is an object as well. That's bloody annoying.
You know, that's the funny one. That one
Mhm.
actually slightly bothers me less,
Ah, really?
interestingly enough. I get why that is. Let's put it this way. But again, I
Mm,
think that's a different discussion. And there is one more thing that I would like to touch on before we finish, and it kind
mm,
of goes to the fact that, as you mentioned, whenever converting a project, there's likely a utils folder. And on the one hand, you want to start there because probably everything is dependent on utils, but utils is probably not dependent on anything, or at least not on anything internal.
yeah,
Um, and and the the question, but on the other hand, it's the one that's most likely to need advanced TypeScript features like generics and stuff like
100%.
that. So you're probably also starting with the hardest part. And my question here is, so generics, like, does every TypeScript developer need to understand generics, or is this something that we can be relegated to a few, like, quote unquote TypeScript wizards? And in this context, I think it was Theo. Uh, if I'm mistaken, then I apologize. Who once in a video kind of made a distinction between the TypeScript at the app level versus TypeScript at the library level. That
Mm,
when you're working at like the userland slash application level, you can be you don't need all the fancy schmancy JavaScript TypeScript features. It's basically mostly simple or very explicit types. But
mhm,
when you work at the library level, then you probably need to get into various APIs sorry, you need to deal with sophisticated APIs, and then you need stuff like generics, and we talked
yeah,
about covariant and contravariant and stuff like that.
mm,
Um, So do you agree with this distinction? Do you think it should exist, or does every TypeScript developer need to know generics sooner or later?
So, let me break this down in a couple of places. The first place I'll break it down is that generics as a concept, I think there's kind of two things in there, which is that there's generics as a consumer, which is basically the person consuming the functions, calling the functions. You need to know, for instance, how to pass a type to another type, which is generics. So if you have an async function, you need to understand how the promise type helper works, which is, of course, a generic type. But then the thing that I suppose we're really talking about is generic functions, declaring your own generic functions, designing APIs. If you're in the business of designing an API, and I mean like an API for a function that other people are going to call, then you will probably need some generics at that point. And that's when we start to get this sort of spectrum coming in of we've got the app developers on one side who are mostly just consuming generic functions, and then we've got the library developers on the other side who are creating the generic functions. And this sort of is a nice feature of TypeScript, I think, because it means that a lot of complexity can just be held inside those generic functions and then just used in a very simple way with very few type annotations by the app developers. I would say I think of there as being three places, three sites of three levels of TypeScript wizardry, let's say, where you have the app developers on one side. You do have the library developers on the other side who have to deal with all sorts of stuff like infer and conditional types and TypeScript performance, which is the performance of your types, how fast does your IDE update and things like that. And then I'd say that the utils folder is like a level in between, where you don't necessarily need, and this is not my idea, this is actually Auto the Rox's idea, who's a great TypeScript, was on the TypeScript team, great TypeScript contributor. And the utils folder, I think you can get by with just a bit of TypeScript knowledge, especially now you have things like ChatGPT with Claude that can help you out a little bit with these. If you can declare a generic function, declare a generic type, I think that is going to really help you just in terms of your app development, because it's going to mean that you can design your types a lot better. You can make types that sort of flow in beautiful ways. You can make make functions that do what you want them to on the type level as well as the runtime level. And so if you're starting and it's like your first month doing TypeScript, don't dive into generics immediately. There's no need. You can just consume generics, just do that. But I think that as your apps grow, as more code gets shared, more code goes into the utils folder, knowing this stuff is going to just benefit you enormously.
Yeah, I think that's the key point. I think it's totally fine to start before you're quote unquote an expert. If we all waited to become expert before we actually started doing something, that we would never stop. Like the worst enemy of good is better. Fake it till you make it, and whatever is actually a legitimate approach in this context. That said, don't stop. If TypeScript is a core part of your development process, then I think that you owe it to yourself, to your career, to your team, to your product to become as proficient as possible in it. And I think that it's definitely worthwhile to put in the effort to go to websites like yours, to read the newsletters that you put out, to try things out, to make sure that you do understand, how things actually work and stuff like that. So as long as say, okay, I am going to put in the effort to fill in the blanks, I think it's a legitimate approach.
Yeah, and learning this stuff as well, learning the mental models behind it, they just benefit you so much when you're building stuff, because you don't get stuck so often. You can just work your way through errors. You can understand what's going on.
Now, if you've got another minute or two, I want to pick up one question that we got in one of the chats. Let's see if I properly understand it or if you do. It's from either Powan or Pawan. I hope I'm pronouncing it correctly. And he asks, how can we automatically convert TypeScript to runtime assertions? What are the options and the tool sets?
Yeah, so one key part of TypeScript understanding is that it just doesn't operate at runtime at all. Like it's
It's gone.
gone. It's just, like they are just cleaned out, those types. And so
You
there is
can't
no,
iterate. You can't iterate over, like a lot of people like say like hate the fact that you kind of define certain things like twice. Part once as values and once in types, and one can't I iterate over the type. You can't
yeah,
because it's not part of the runtime.
not part of the runtime. They just don't exist at runtime. And so this question is sort of asking, how do I make a type and sort of put it into the runtime? And you probably could with some kind of code gen library, an LLM could probably do it for you. But yeah, I mean, there's no, I think people who ask this question are asking the wrong thing, which is instead of taking a type and putting it into the runtime, you should be thinking, how do I take the runtime and turn it into a type? Because there's
Exactly.
a really nice operator called the typeof operator in TypeScript, which it's same as the JavaScript operator, but sort of operates slightly differently, which just lets you basically, if you're using something like Zod, which is a runtime validator, runtime schema library, then you can take that and you can say typeof z.schema, and it just gives you a type
The
out. So
simple
that's,
example, the simple example is keys. Is the
yeah,
fact that you can use specify like an object with various keys, infer a type from that. So now you've got the actual object which you can use at runtime, but you've
yeah,
also inferred the type that you can use at, build/programming type.
yeah, totally. A really good example is, let's say you have an object of APIs that you want to hit with different sort of environments attached to them. So you have your QA environment, your development environment, and your production environment. You have that on an object. You can pull those keys off, and suddenly you have a union of those three keys. So I call this derived types, where you basically derive some sort of type from the type of another thing. And this can be really powerful because it means that you don't need to maintain the type in two places. You just add another key, you add a staging environment, and then that suddenly appears in the type. It's really, really powerful stuff.
So before we really run out of time, if people want to get in touch with you to, get on your newsletter, your website, your book, whatever, what's the best way to find you? How do we, find all your stuff, the excellent stuff that you're putting out?
Thank you. So this is totaltypescript.com is basically the site where I put pretty much everything now. So there is a newsletter there. There is my free book on there, which, I mean, a free book, it sounds like it's just sort of cheap giveaway. It took me 9 months to write this thing, you know what I mean? Like, and it's being released as an actual paper book as well. And I've got a course up there, and there are tons of free tutorials and about 60 articles I've written up there. It's a really solid resource.
And in terms of paid stuff that you put out, what is there?
Yeah.
What's
So
available?
I've got two courses really, or two levels of courses. One which is Pro Essentials, which is, I mean, it's about 240 exercises, I think, where basically just takes you from total beginner in TypeScript to sort of like the bottom end of wizard, I'd say. So we cover generics in there, we cover all sorts of stuff related to TypeScript. And then the other stuff, which is the complete volume, is I've got a series of really advanced workshops, which I taught live, which are basically sort of, I turned into a self-paced course as well. So the whole thing, I think it's about 500 exercises or so. Like, it's an enormous, great big thing. And, but I love the exercises because you can just sort of dive into them in your lunch break, basically. It should take about sort of 5 or 10 minutes to solve each. And we've gotten feedback that it's just like a really addictive process. You just go bam, 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 solving all the exercises, and it's great fun.
And the very last thing before we let you go, is there anything interesting that you're working on now? Something that we can look forward to?
Well, I'm diving into the world of AI, I think, and I'm starting to find that I'm someone who's kind of allergic to hype. Really, I just hate the whole hype cycle for things like crypto, and I just want to get to the interesting stuff and the meat that's going to kind of make me more money or make companies more productive, or like somewhere I can provide value. You know what I mean? I don't want to speculate on crypto rubbish. And AI is got a lot of hype around it, but it's also very, very real and based on a lot of good science. And yeah, I'm finding it very, very interesting and potentially thinking about making something from it.
Oh, so very cool. So, people are used to us also having a pick section, but I think we kind of ran out of time. I will love to have you on again. There are so many questions on my list that we didn't get around to, and we didn't speak about AI at all. So hopefully I can get you on again. In any event, it's been excellent. I've learned a lot. It's been such a joy speaking with you. I hope our listeners have learned as well. So thank you for coming on our show. And to all our listeners, thank you for listening to us. And again, reminder, if you're thinking about filling in the JS survey, mention us, given excellent content like this one. And thank you all and goodbye.